Welcome, geometry students, to another Regents review video. This is going to be the August 2016 Geometry Common Core Regents exam. These will be the solutions for Part 1, questions 13 through 24 for the August 2016 Regents exam in geometry. Before we begin, just a quick reminder that please do not cheat on this or refrain from cheating because the Geometry Regents is quite difficult. If you are here to check your answers or to seek guidance, I am always here to help. So please take advantage of these videos and hit that subscribe button down below. And please visit my website at www.nysmathregentsprep.com for much more math content. Without further ado, here we go. Jump into question number 13 on the August 2016 test. Here we go. 13 says the cross-section of a regular pyramid contains the altitude of the pyramid. The shape of this cross-section is a what? Okay, the vocabulary or the wording of the question really gets me a little irritated. It says the cross-section of the regular pyramid contains the altitude. That's important to get this right. So the first thing that I want to do personally is I want to draw a pyramid. Now, a regular pyramid is a pyramid with a square base. Okay, so let me just draw a quick pyramid, and then what I want to do is I want to draw the cross section. Okay, so this, ladies and gentlemen, is a pyramid, and it specifically says to us that the cross section contains the altitude. So what does that really mean? Well, if I were to construct the altitude of this pyramid, what cross-section is this? Well, a few more things that we need to look for. This right here. This figure that you see, that two-dimensional flat-shaped figure, is a triangle. And the triangle contains the altitude inside of a pyramid. So the answer for number 13 is going to be choice 3, a triangle. All right. Moving on to 14. The diagonals of rhombus team intersect at P21. If the equation of the line that contains diagonal TA is y is equal to negative x plus 3, what is the equation of a line that contains diagonal EM? First and foremost, draw yourself a picture. So, I'm going to draw a rhombus. And remember that a rhombus has 4 congruent sides and that the diagonals are perpendicular bisectors of each other. So these diagonals create right angles. Okay, so I'm going to also label it as TEAM. Okay, so and they intersect at P, which is the point 2, 1. Great. So they're saying here, if the equation of a line that contains TA, which is here, is equal to y is equal to negative x plus 3, what is the equation of this line here is what they're asking you for. So you need to know a couple things. The diagonals in a rhombus, are perpendicular. So what that means is if the slope of TA is equal to negative 1. Now, I know it doesn't look like that on the diagram because it's positive, but they told us that the slope is negative 1. But if the slope of TA is negative 1, then the slope of EM must be the negative reciprocal of negative 1, which is going to be positive 1. So the slope of ME is going to be 1. So we could get rid of choices 3 and 4. We have to look for the line that contains a slope of 1. In this case, it's choices 1 and 2. Now what we need to do is we have our slope, and we have a point that it passes through. We could use the point slope form, which is y minus y1 equals m times x minus x1 to calculate the equation of the line. So we get y minus 1 is equal to the slope of 1 times x minus 2. Now we don't need to distribute that 1 because 1 times anything is just itself. So we get y minus 1 is equal to x minus 2. I'm going to add the 1 on both sides. You get y is equal to x minus 1. which is going to be choice 1. And that is the equation of the line of EM. All right, cool. Moving on to number 15. The coordinates of vertices A and B are of triangle ABC are 3, 4, and 3, 12. If the area of triangle ABC is 24 square units, what could be the coordinates of point C? This question was definitely interesting. So the first thing that I'm going to do is I'm actually going to put a grid on this question. And you could use your graph paper in the back of the Regents exam. Now, the problem is this graph that you see here, it's a 10 by 10, so I have to actually extend 2 more lines above. So I'm going to do that right now. Just bear with me while I do that. Okay, there we go. I'm going to extend that line too. Okay, so here we go. I am going to graph the points 3, 4, and 3, 12. So 3, 4, 1, 2, 3, 1, 2, 3, 4. That's coordinate A. And B is 3, 12. That's all the way up here that I just drew. And it's telling you that the area of the triangle is 24 square units. What could be the coordinates of point C? Okay, so we already know that this right here, this line is the base of the triangle. Okay, that's the base of the triangle, which is equivalent to 1, 2, 3, 4, 5, 6, 7. That's 8 units. We need to create a height of the triangle that has 6 units, because the area formula of a triangle is 1/2 base times height. If they tell you that the area is 24 already, and that's equal to 1/2, and we know that the base is 8 times the height of the unknown, we don't know what the height is. 1/2 of 8 is 4. 24 is equal to 4h. Divide by 4 on both sides, and you get h is equal to 6. So the height of the triangle has to be 6. And the height has to be perpendicular to the base of the triangle. So which coordinate does that? Well, let's plot 3, 6. 3, 1, 2, 3, 4, 5. That doesn't even create a triangle. That's on the line. That can't work. 8, -3. That doesn't have a height of 6. It's impossible to create that height. -3, 8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute. Does that have a height of 6? Well, let's count it. 1, 2, 3, 4, 5, 6. Look at that, ladies and gentlemen. We found our coordinate. It is the point -3, 8. And that will produce the area of 24 square units for triangle ABC. And that's all you have to do with that question. It's easiest if you graph it, I promise you. All right, number 16. What are the coordinates of the center and the length of the radius of the circle represented by the equation x squared plus y squared minus 4x plus 8y plus 11 equals 0? You have to use the completing the square method. Now remember, I tell everyone, keep your letters on one side, numbers on the other side. So I'm going to move that 11 over. Okay, so we get x squared, and I am going to group my x's and my y. So x squared minus 4x plus y squared plus 8y is equal to -11. Okay, now I'm going to fill in blank spaces, okay, to create a perfect square trinomial. This is the completing the square part. X squared minus 4x plus something plus y squared plus 8y plus something is equal to -11 plus these 2 blank spaces. Now, in order to figure out what goes in those blanks, actually, I'm going to make more room for it because that is squished up there. Hold on 1 second. Right now, I want you to be thinking about what goes in these blank spaces. Well, you need to apply the formula b divided by 2 squared. It's half of the linear term, which these are the linear terms, the -4 and the +8. Those are your linear terms. You have it and square it. If you take half of -4, half of -4 is -2, and then -2 squared is 4. That's your b divided by 2 squared. Now you take half of 8, which is 4. 4 squared is 16. And when you do to one side, you must do to the other side. So now what I'm going to do is I'm going to say, hey, wait a minute. Now we could factor these. You couldn't factor in the first place. Now we can. That's great. So now we could just say, all right, what adds to -4 and multiplies to give you +4, and then what adds to give you 8 and multiplies to give you +16. That is going to be x minus 2 plus y plus 4 is equal to negative 11 plus 4 plus 16. That's going to be equaling 9. Now, we could rewrite x minus 2, and y plus 4 as x minus 2 squared plus y plus 4 squared is equal to 9. Now, ladies and gentlemen, this is your center radius form of the circle. So therefore, your center point is going to be the opposite values of what's inside, which is 2 comma negative 4, and your radius is going to be the square root of 9, which is 3. So your answer is going to be choice 1, the center of 2, negative 4, and the radius of 3. Okay, that's how you do it algebraically. Right now, just a quick moment, I just want to show you how to do it graphically on the TI Inspire. Did you know that circles can be graphed on this TI Inspire calculator? If you didn't know that, you're in luck, because I'm about to show you. If you go to Menu, and then go to Graph Entry Edit, go to Equation Templates, click on Circle, and then you click on Standard Form, which is what the problem was in the first place, I can now type in the values. And if you look at your problem, you see all these boxes here, just fill in those numbers. So there's a 1 in front of the x squared, there's a 1 in front of the y squared. There's a negative 4 in front of the x, but keep in mind in the calculator it's a plus. So we need to make a minus 4. Then we have positive 8y, and this is going to be positive 11, and press enter, and there's your circle. Now what I could do is you could click on Menu, Analyze Graph, Analyze Conics, and click on Center Point. Hover over the circle, and it produces 2, negative 4. Do the same thing to get the radius. Menu, Analyze Graph, Analyze Conics, and now we're looking at the radius, which if you hover over the circle, you get 3. And that is how you match up your answer. All right, so that is your center, and that is your radius. Cool. All right, number 17. This is a good question. The density of the American white oak tree is 752 kilograms per cubic meter. If the trunk of an American white oak tree has a circumference of 4.5 meters and the height of the trunk is 8 meters, what is the approximate number of kilograms of the trunk? Okay, let's talk about this for a second. The question's asking the approximate number of kilograms. Okay, kilograms. What is kilograms? What is that? What is that a unit of? Kilograms is a unit of weight. Okay? And the 752, it says it's 752 kilograms per cubic meter. That should be buzzing around in your head as the density. Ladies and gentlemen, this is the classic example of a question of weight is equal to density times volume. Expected on the Regents, it's going to show up. Now, the trunk of an American white oak can be represented. Now, there are things in life that are not perfect geometric figures, but we can model them. Model means to approximate what it is. A trunk can be modeled by a cylinder because a trunk does look like a cylinder. So what we do here is we just create a cylinder, and what we are going to do is we are going to solve for the volume of this cylinder. Now, a couple of things that they tell us about this cylinder. They tell us that the circumference is 4.5 meters. Well, they tell us that the circumference is 4.5, but what does that really tell us? Well, we need to find the volume of the cylinder. So the volume formula of a cylinder is pi r squared times the height. But we don't have the height. But we don't have the radius, but we do have the height. We need to solve for the radius. How do we do that? It's all based on circumference. You know that the circumference formula is 2 pi r. We could solve for r if we're given the circumference. So if we're given the circumference of 4.5, we could set this equal to 2 pi r and solve for r. So if we divide by 2 pi on both sides, we get r is approximately equal to, now if you type 4.5 divided by 2 pi in your calculator, you get 0.716. That's the length of your radius, ladies and gentlemen. So now what I'm going to do here is I am then going to plug in my radius into my volume formula. So volume is equal to pi times the radius of 0.716 squared times the height of 8. They tell us that the height is 8. The volume is now approximately equal to 12.892. Okay, so now last but not least, we are then going to take our volume and our density, and we're going to plug it into the weight formula. Weight is equal to density, which is 752 times 12.892. When you plug that into your calculator, you get 752 times 12.892. You get 9,694.784, which is going to be choice 2. And that is the correct answer. All right, number 18. I say this all the time. I teach this differently than most teachers. Here we go. Point P is on the directed line segment from point X, -6, -2, to point Y, which is 6, 7, and divides this segment into a 1:5 ratio. What are the coordinates of point P? I use formulas. Your teacher may graph these. I don't do that because I find that to be not pointless. I just find that that you might not have a good understanding of what's really going on here. I'm trying to take my points that I have and create a ratio and generate a ratio to create similar segments. So the formula to generate the x value is x minus x1 over x2 minus x is equal to the given ratio. This is the example of a partitioning of a line segment. And when you partition a line segment, it just simply means that the point is in a weird location on the line. All right, so these are your two formulas that you need to know. So your x point, that's your x1, y1, and your y point is your x2, y2. I am then going to plug in this information separately. So you get x plus 6 over 6 minus x is equal to the given ratio of 1/5 expressed as a fraction. Then you cross multiply, so we get 5 times x plus 6 is equal to 1 times x minus, 6 minus x, I should say. Okay, distribute that 5, we get 5x plus 30 is equal to 6 minus x. Add the x on both sides. We get 6x, I'm going to subtract the 30 as well, is equal to negative 24. Divide by 6 on both sides, and you get x is equal to negative 4. Now we're going to do the same thing for the y values, except just use your y coordinates. So we get y plus 2 over 7 minus y is equal to the given ratio of 1/5. Multiply by cross multiply, so we get 5 times y plus 2 is equal to 7 minus y. Distribute that 5, we get 5y plus 10 is equal to 7 minus y. Add the y on both sides, and I'm going to subtract that 10. So we get 6y is equal to negative 3. Divide by 6 on both sides, and you get y is equal to negative 1/2. And the correct answer for this, if it's negative 4, negative 1/2, that is going to be choice 4. Then that is the correct answer for number 18. Okay, number 19. Now, I want to make this clear. Number 19, if you're working out of a Barron's book or if you're working out of one of those little green books by the Topical Review Book Company, this still has a typo on it. What the Regents did in August is that they realized that they made a mistake on this question and they omitted it and they gave everyone credit. But then what they did is when they released the exam, they fixed the question. So make sure that it is the updated Regents exam. All right. So it says here, number 19, in circle O, diameter AB, chord BC, and radius OC are drawn, and the measure of arc BC is 108. Some students wrote these formulas to find the area of the sector of COB. Stop right there, without even looking at the student's work. The area of a sector is n over 360 pi r squared. Make sure that you know it. Now we're looking at all these people's works. Which students wrote the correct formulas? So, what do we know? Well, we're trying to find the area of the sector of COB. So we're looking for the area of this pizza slice. Okay? Now, this angle that you see over here, that is a central angle. So it is actually the same measure as this. So your central angle is 108. Now, the radius, they don't even tell us the radius length. But we know that the radius is either OB or OC. Okay? So let's take a look here. Amy says that it is 3/10 times pi times BC squared. Okay, just by looking at this BC squared, BC is not even a radius. So therefore, Amy is incorrect. So get rid of choices 1 and 3. Let's take a look at Beth. Beth says that it is 108 over 360, so that's good. 108 over 360, that's your n value, times pi times OC squared. OC is a radius. So Beth is correct because that is A is equal to n over 360 pi r squared. Great. By the way, I mentioned that there was a typo. This was the typo. If you have an old book, Carl's formula is 3/10 pi, 3/10 times pi times 1/2 of AB squared. That is not the same thing. So make sure that you fix this if this is in your book or whatever you have. All right. But if you look at Carl's formula, where's he getting this 3/10 from? Did I mention that 108 over 360 is 3/10? I should have. So 108 over 360 is 3/10. Okay? That is equal to 108 over 360. Okay? So that is A is equal to 3 over 10 times pi times, okay, well, 1/2 of AB squared. Well, AB is a diameter. And the diameter is double the length of the radius. So we take 1/2 of the diameter to get the radius and then square it. So Carl is actually correct. So your answer is going to be choice 2. Beth and Carl are correct. Dex is wrong because, oh, look at that. He made that error, just like Carl did in the old Regents exam. But Carl and Beth are correct. All right. And that is going to be choice 2. Number 20. 20 makes my brain work. It's a pretty cool question. Number 20 says, tennis balls are sold in cylindrical cans with the balls stacked one on top of the other. A tennis ball has a diameter of 6.7 centimeters. To the nearest cubic centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? Okay. So they tell you that the diameter is 6.7. I actually drew a nice little diagram of what this would look like. These are your 4 tennis balls in one can, in a cylindrical can. So they tell us that the tennis ball has a diameter of 6.7. That's really interesting. If I zoom in here onto my diagram that I created, look at this. Look at this. The diameter of one of those tennis balls is going to be 6.7. So this little green line that you see is 6.7. Keep in mind that all of the tennis balls are stacked one directly on top of the other. This line is also 6.7. And this line is 6.7. And this line is 6.7 because they're all diameters. So all of these lines are 6.7. Now I'm specifically talking about it stops at these points. So this is 6.7, this is 6.7. So all of the diameters are 6.7. But if you add up all of these diameters, that gives you the total height of the cylinder. So that's 6.7 times 4. Your height is actually 26.8 of the cylinder. Now, what is the length of the radius? Well, the radius, which is from here to here, is 1/2 of the diameter. The diameter of the tennis ball is 6.7, so therefore your radius is going to be 3.35. So now using your formula, which is volume is equal to pi r squared times the height, we're going to plug that in. Pi times the radius of 3.35 squared times the height of 26.8. So pi times 3.35 squared times the height of 26.8, and we get an answer of 944.8, which is about 945, which is going to be choice 4. Moving on to question 21. Line segment A prime B prime, whose endpoints are 4, -2, and 16, 14, is the image. This is a big reading test. A prime B prime is the image. That means that it is a result of what was done to line AB. So it says, is the image of line AB after a dilation of a half center of the origin. That means that A prime B prime, the distance of A prime B prime, is less than the distance of line AB, because this line AB, the original, was dilated by a scale factor of a half to get A prime B prime. Okay, that's important. So we know the distance of line segment A prime B prime because they tell us the coordinates. So let's go ahead right now and find the distance between these 2 points. So remember that the distance formula is x2 minus x1 squared plus y2 minus y1 squared. D is equal to the square root of 4 minus 16 squared plus negative 2 minus 14 squared. D is equal to the square root. Let's see, this is going to be, all right, I need to type this into my calculator. 4 minus 16 quantity squared, that's going to be 144. So 144 plus negative 2 minus 14, that's negative 16 squared. Negative 16 squared, that's an answer of 256. So it's 144 plus 256. That is the distance is equal to the square root. It looks like 400. So the distance is equal to 20. Now that is the distance of line A prime B prime. What is the distance or the length of AB? Well, if the distance of A prime B prime is 20 and AB was dilated by a scale factor of a half, in order to get back to the original, you need to reciprocate the scale factor dilation. So we are going to take 20 and multiply it by the number 2 to get back to the original, which is going to be a length of 40. So your answer for number 21 is going to be choice 4. That is the length of the original line. Number 22, given triangle ABE and triangle CBD shown in the diagram below, with DB being congruent to BE. Which statement is needed to prove triangle ABE congruent to triangle CBD using only side angle side is congruent to side angle side? So we are drawing these triangles here. Okay? Now these 2 triangles are congruent by side angle side. They're telling us that. Angle B is the one that's reflexive. I want you to notice this, and it's very tricky to see, but I need you to notice this. Look at the yellow triangle. This is your side, that's your angle, and this BC is your side length. But the problem is we have BE. We're missing the length of EC. And it's the same deal with the other triangle. If you look at the blue triangle, we have the side, and then we have the angle, then we have the side, but again, we're missing the length of AD. So we need, in order to prove these 2 triangles by side angle side, we need AD to be congruent to CE, because AD and CE fills the gaps of one side. So that's all we need to prove these triangles to be congruent. So therefore your answer is going to be choice 3 for question number 22. Almost there. Question number 23. In the diagram below, BC is the diameter of circle A. Point D, which is unique from points B and C, is plotted on circle A. Which statement must always be true? So D is somewhere on the circle. It could be here. It could be anywhere on the circle. So let's examine the triangle that's formed by point D. So I just drew triangle BCD. Okay? Now, this angle over here is an inscribed angle. And this inscribed angle intersects or intercepts a semicircle. Well, any inscribed angle that intercepts a semicircle, this angle has to be, in fact, a right angle. Because an inscribed angle is 1/2 the arc it intersects, and if this arc length is 180 degrees, then this has to be a 90-degree measurement. And that happens anytime you plot point D anywhere. D over here, that creates a triangle as well. Again, it intercepts a semicircle. This has to be 90 degrees as well. So your answer is going to be choice 1. Triangle BCD is always going to be a right triangle. Choices 2, 3, and 4 make absolutely no sense because I mean, look, choice 2 could sometimes be true, but we're looking for the one that's always, and choice 1 is definitely the one that is always true. All right, question number 24, the last question in this video. In the diagram below, ABCD is a parallelogram. AB is extended through B to E, and CE is drawn. If CE is congruent to BE, and the measure of angle D is 112, what is the measure of angle E? So you need to know that in a parallelogram, opposite angles are congruent. So if this angle over here is 112, then the opposite angle has to be 112 as well. So take a look at this. That's a line, and that's a linear pair. Linear pairs are supplementary, so therefore they add up to 180 degrees. So in order to solve for this angle over here, it's just going to be 180 minus 112, and that's going to give you an angle measurement of 68 degrees. Now, we need to focus on one more piece of information. This triangle right here is isosceles. Why is it isosceles? Because CE is congruent to BE, and in an isosceles triangle, if you prove, that is an ugly triangle symbol, but if you prove two sides to be congruent, which they tell us already, if you prove two sides to be congruent, then the triangle is isosceles. So therefore, the opposite base angles are congruent. So if this is 68, then this angle up here is 68. Now, in a triangle, there's 180 degrees. To solve for the measure of angle E, it's just going to be 180 minus 68 minus 68. When you plug that into your calculator, you get 44 degrees, and that is the measure of angle E. That's going to be choice 1. All right, I hope that this helped you. Please subscribe to this YouTube channel with a lot more math content coming, and it's already up there already. And please visit my website at www.nysmathregionsprep.com, and I hope to see you soon.